So, welcome back to our Cloud Unlock. This is our podcast where we talking about some cloud related things. So, this podcast we have our guest Samar Pawar. So, let, we- let's start.
Thank you, Harsh. I love to be a part of this podcast. Uh, the Our topic is related to our daily life because that exactly what happens. Resource sharing and pooling is one of the those invisible technology you are never seen, but your entire digital life depends on it. Every app you use, every file you store in online, everyday videos you're streaming, it's a made possible because thousands of people are sharing the simple pool or same pool of the computing resource efficiently, securely, and seamlessly.
Oh, that was a very powerful statement. Let's start from the absolute zero. Imagine I am a student just who heard about the word resource cooling in a cloud computing for the first time. So, what picture would I you paint for me?
Okay, let's use a really simple analog. Picture a large, well-stocked public library. The library has thousands of books, dozens of computers, comfortable reading rooms, and fast internet. Nowadays, every person who walk in a wall own of that do not know, don't they get a USE all of it? Yes, as much as they need. When they need it, when they leave, thousands of resources go back into a pool and someone else use them. That's resource sharing. The library doesn't buy a separate building for every reader. It pools a resource, books, chairs, computers, and shares the intelligently among all users. Cloud computer is exactly this, but for a computing power, memory, storage, and networking.
Oh, and why this is better than everyone having their own private library or in technical term their own private server.
Because of sometimes something called as a economy of a scale combined with a law of averages. Here is the thing, not everyone needs a maximum resource at the same time. Right now you might be reading while I am talking while someone else is sleeping. We all have a different usage, power, and money, but if we are pool these resources together, someone is always using them. The pool stays active efficiently, goes up to dramatically, costs go down dramatically, and everyone gets a resource they need when they need the magic.
Hmm. Let's formally define resource sharing. What exactly does it mean in a cloud computing?
Resource sharing in a cloud computing means that multiple users, sometimes called tenants, or simultaneously use the same underlying physical infrastructure. These include CPU, cores, RAM, and network bandwidth, storage disk, and even software license. The key word is across Amazon or Google data centers. None of the none of them see each other. None of them interfere with each other, but they are all using the same physical machines managed by software that divides and allocate resources intelligently.
Hmm. So when I run my website on the AWS, my website is technically sharing hardware with the thousands of websites.
Exactly right. You AWS EC2 instance, your virtual servers is probably on the some same physical machines as a dozens of people's virtual servers. You don't know, they don't know it, and more importantly, you don't feel it because the hypervisor create a perfectly isolation environment for each VMwares, and you get the a dedicated of a CPU or a dedicated slice of RAM, your own network interface, all curve out of the shared physical resource. It's like a living in an apartment building. You shares a same building in a same roof, the same elevator, but your apartment is a private space.
Okay. So what key principle that make the resource sharing work?
It's a great question. These are a five core principles. First one is abstraction. The physical hardware is abstracted away. Users see virtual resources, not a physical one. These allow the underlying hardware to shared without exposing it. Second one is isolation. Everyone thought resources are shared, each other environment is isolated. Your data, your processors, your network, all are private. Third party transparency is not allowed. The shared is individual to the user. You feel like you have your own dedicated server even though you don't. Fourth one is fairness. Fairness is a resource sharing system uses scheduling algorithms to ensure no one single user monopolizes the share resource. Everyone gets the fair share. And fifth one is accountability. Everyone, every unit of a resource consumed is a tracked and a blind accordingly. Pay for what they use or nothing more.
So now let's talk about the resource pooling specifically. How is it different from just a resource sharing?
Think of a resource sharing as a concept, the idea of a multiple users using the same resources. Resource pooling is a mechanism, the technical implementation that makes share possible. In a resource pooling, physical computing resource like CPU, memory, storage, network are arranged into a massive centralized pool. The pool is dynamically allocated to the users and on their demands. The key characters of a pooling it's that a located independence. You don't know which physical server in which data centers is a server your request. And more importantly, the cloud doesn't lock any resource to specific users. Resource flow in and out of the pool dynamically based on a demand.
Hmm. So the pool is like a giant visible reservoir of a computer power.
Perfect analog. There is imagine a city, water reserve or oil reserve. If we consider a water reserve, water from many sources, rivers, rainfalls, groundwaters, flows into a central reserve oil. When you turn when you turn on your tap, water flows from water store to your home, and you don't know which river you specifically water comes from. You don't care. You just get a clean water and demand as you need it. When you close the tap, the water gets back into their cycle. Resource pooling works exactly like that. Computing resource flow into the pool from a many physical servers and flow out of a users on demand. When users realize resource, they return to the pool for other uses.
So what are the defining characteristics of a resource pooling according to the cloud computing standards?
The National Institute of Standards and Technology means NIST also define the very formally. They list resource pooling as one of the five essential characteristics of cloud computing. Especially, they says the providers' computing resources are pooled to serve multiple consumers using multi-tenant model with a different physical and virtual resource. Location dependence, their customer generally has a no control or a knowledge over the exact location on the provided resource. This is a official definition, but let me translate it in simply. Big shared pool dynamically manage a location doesn't matter. Users get what they want and what they need.
So can you draw a clear line between the resource sharing and the resource pooling? They are some exactly similar.
They are related, but they are different. Resource sharing is the outcome, what users experience. Resource pooling is the infrastructure, how it builds. Think of this way. Resource pooling is how the library organize their collection. All books are in central location, managed, ready to borrow. Resource sharing is what they need or what they come in a borrow for what they return it. The pool enables to the sharing without pooling sharing at cloud scale, what be impossible. You don't have manually track which user get which physical resource chose at a millions of users. Pooling automates that entirely thought software definited management.
So pooling is a backend infrastructure, and the sharing is a front end
Uh,
experience.
uh, Precisely, and here's another way to think about it. Sharing without pooling would be like having a library where every book is still owned by the original author, and you have to negotiate with each author separately to borrow it. Pooling without sharing would be like having a warehouse full of books that no one can even borrows the book. Cloud computing needs a both a well management central pool and a fair sharing mechanism to distribute it together. They create the elastic on demand pay per use model that defines cloud computing. Resource pooling technical architecture makes a physical resource into a centralized dynamically and managed resource. And next, resource sharing, the user experience multiple talents consuming the same pool infrastructure simultaneously. Together, they get a foundation of multi-tendency, efficiency, and elastic scaling in a cloud.
Okay, so what is the different type of resource that gets pulled in a cloud computing?
There are four major types. Let's me walk through each one. First one is compute pooling. This is a pooling of CPU and memory resources. Physical servers contribute their CPU cores and RAM to a share a computer pool. The hypervisor the allocates slice of a compute pool to the virtual machine on the demand. When VM is created, it get allocated to stay 4 virtual CPUs and 8 GB of RAM from a pool. When it's deleted, those resources return to the pool. AWS EC2, Azure Virtual Machines, Google Compute Engine, all are the computing pools.
So, and what is the second type?
Second type is a storage pooling. Physical hardware drives in SSDs from many storage servers and combined into a massive virtual storages. Technologies like a store area networks, SAN, and software-defined storage platforms like SIP or Amazon S3 do this. When you upload a file cloud storage, it doesn't go to a specific disk. It distributes and stored across the pool. Often the redundancy, if one disk fails, your file is safe because copies are exit everywhere.
Then what is the third and fourth?
Third one is network pooling. Physical network equipment switches like a switches, routers, cables, and abstracted into a virtual machines or virtual network. Technologies like SDN, software defined networking, to create a virtual private network for each customer dynamically. Your traffic flows through a shared physical cables, but are logically isolated in your virtual network. Fourth is a memory pooling. This is an advanced concept where a RAM for multiple physical servers can be aggregated and across as if were the large memory space. Technologies like remote direct memory access (RDM) enable this. Use high performance computing in a memory database like SAP and HANA on a cloud.
Hmm. So now, what are the actual technology powering the resource pooling? Like what software, what hardware are doing all of this?
Great technological question or great technical question. Several layers of a technology work together. At the bottom, virtualization and hypervisor. We talk about the last episode or the hypervisor type one like VM where AWS Nitro is a core engine that creates a manages virtual machines from a pooled physical resource. It's a traffic control of a compute pool. Above that, software-defined infrastructures, this is a philosophical of a replacing hardware dependence. Management with a software driver management, software-defined compute, software-defined storage, software-defined as a networking. All of these are allow resource to be pulled and managed programmatically through a code as a API rather than manual hardware configuration.
Now let's talk about what about the container and do they play a role?
Absolutely. Containers are play a role, especially adding another layer to the resource pooling uh, to takes a cluster of a machine and pooling their CPUs to the RAM into a undefined computer resource. When you are deploy an application, the system contribute on their to place if within the pool of optimizing a resource usage. It does been packaging fitting as a many contributors or containers as a possible into available resource without any overloading in any single machines. Thinker of it like a master puzzle solver that knows the exact size of the container at fits them perfectly across the machine of a pool.
Hmm. Now let's prove that with a number. Can you show mathematically why resource pooling is a more efficient?
Yes, let's build and model step by step. Scenarioing the number of pooling each other 10 companies has a own dedicated servers. Each server has 100 unit of a capacity. Each company uses on and 20 units. That 20% of utilization rate. Total capacity across 10 servers means 1000 units are total use and 200 units are total 200 units are also there. Total waste of 800 units was a ratio of 80%. Now this scenario with the resource pooling, those 10 companies share the single pool servers with 100 units of a capacity. Their usage doesn't all peak of the same time. This is law average working in a favor. When the companies at a peaking, company A and company B is a quiet. When the company C is busy, company D is ideal. Combine the average usage of across 10 companies simultaneously. Typically 60 to 75% utilization is used.
Hmm. So pooling reduce waste from 80% to 20 to 40%.
Exactly, but it gets better because it is a statical multiplexing. The math of shared networks, the more users in the pool, the more stable and efficient the average utilization becomes with a 10,000 companies in a pool, which are realistic for AWS. The average no single company's usage speak in or significant when you are averaging over thousands. This is a this is why AWS can sell 10,000 virtual servers worth of capacity, maybe 2,000 physical servers. It's a not a magic. It's a statical pooling that's 5x efficient multiple.
Hmm. So can you put the efficiency gain into the formula?
Sure, it's defined pooling efficiently in gain in passages of a dedicated utilization of 20% and pooling utilization is a 75%. Then it mainly all basis on a physical servers.
Hmm. So let's talk on a money. How does the resource pooling translate into the actual cost saving for a business purpose?
This is where it gets really exciting for business leaders. Let's may lay it clearly. The cost of a ownership for a traditional dedicated servers environment includes hardware pages, cost power of electricity, cooling infrastructure, physical space real in a center data, networking equipment, IT staff for maintenance, hardware refresh every 3 to 5 years, and software license. A typically medium-sized business run in 50 dedicated servers might be spent $2 to $5 million annually on the all this combined.
So and with the resource pooling,
With the cloud resource pooling, you pay only for you what actually use, not for anything else. Hardware purchases, no cooling infrastructures, and no it stuffs for hardware. The space cost and the benefits from the cloud providers economic of scale, they may get a higher beneficial.
So, thank you. That was an amazing discussion with you.
Thank you so much, Harsh, and thank you to everyone listeners who made it a end of the episode. The cloud isn't magic; it is a magnificent or for every listeners who made it a end to end of the this episodes. The cloud isn't a magic; it is a engineering, and now you know exactly how the engineering works. See you in the next episode.
Thank you. Thank you so much.
Thank you.